10 tiny mistakes that triggered massive disasters. Most disasters don't begin with an explosion. They begin much earlier, with something that doesn't look dangerous at all. A socket slips from a wrench. Someone uses the wrong unit in a calculation. A small part of a building design gets changed. On an ordinary day, things like that barely deserve a second thought. But one of those mistakes punched a hole in a nuclear missile. Another helped destroy a spacecraft at Mars. And another ended with 2 crowded walkways crashing into a hotel lobby. That's what makes these stories so unsettling. The first mistake is often tiny. The disaster happens because that mistake is allowed to travel through everything that comes after it. These are 10 cases where something small found a much bigger weakness. And sometimes people even saw the warning before everything went wrong. 10. The dropped socket. On the evening of September 18, 1980, an Air Force technician was working deep underground beside a Titan II nuclear missile in Arkansas. At some point, a heavy socket slipped from his wrench. Normally, you pick it up and keep working. Here, there was one small problem. It had about 80 feet to fall. The socket hit part of the structure below, bounced sideways, and punched straight through the missile's fuel tank. Suddenly, losing a tool was no longer the problem. Rocket fuel was leaking inside a missile silo with a nuclear warhead sitting above it. There was no simple way to undo what had just happened. For hours, crews tried to understand the situation and work out what to do next. Then early the following morning, the fuel vapors exploded. The missile was destroyed. One airman later died from his injuries, and 21 other Air Force personnel were hurt. The nuclear warhead was thrown clear of the silo. Thankfully, it did not detonate. Its safety systems worked, and there was no nuclear explosion. An enormous weapon system had survived countless complicated engineering challenges. And then the whole emergency began with a piece of metal small enough to fit in one hand. 9. The firefighters who couldn't connect to the water. When Baltimore caught fire in 1904, help came from all over the region. Firefighters arrived with engines, equipment, and long lengths of hose. There was water in the hydrants. The crews were ready. Then they tried to connect their hoses. They didn't fit. At the time, American cities didn't all use the same type of connection. A hose that worked perfectly in one city could be useless in another. That wasn't much of a problem when every fire department stayed at home. But Baltimore's fire had grown too large for one city to handle. Now firefighters had come from outside to help, and some of their equipment simply couldn't connect to Baltimore's water supply. Crews tried improvised solutions, but the fire kept spreading. It burned for about 30 hours and destroyed more than 1,500 buildings. For years, different cities had been using different versions of the same basic fitting, and everything worked fine. Right up until one city desperately needed help from another. 8. The spacecraft that got the wrong numbers. NASA managed to send the Mars Climate Orbiter almost all the way to Mars. The spacecraft survived its launch. It survived months in space. It traveled hundreds of millions of kilometers. Then the mission was lost because different parts of the same project weren't using the same units. One side was working with English units. Another expected metric. The numbers themselves didn't look obviously wrong. They were still numbers. The computer had no way of knowing that one group meant one thing and another group meant something different. So as those numbers were used for navigation, the spacecraft slowly moved away from the path NASA believed it was following. By the time the problem became clear, Mars Climate Orbiter was approaching the planet much lower than planned. Contact was lost. The spacecraft was gone. A mission that had crossed the distance between Earth and Mars had been defeated by something students learn in school. But even NASA's investigation made a more important point. The unit mistake should never have been allowed to survive all the checks around it. The wrong measurement started the problem. The fact that nobody caught it finished the mission. 7. The small design change. On July 17, 1981, hundreds of people came to the Hyatt Regency Hotel in Kansas City for an evening of dancing. Some stood in the lobby, others watched from suspended walkways above them. Nobody in that room had any reason to think about the steel rods holding those walkways in place. But during construction, the way those rods were connected had been changed. To most people, the difference would have looked minor, a few pieces of steel arranged differently. But the change completely altered where some of the weight went. Instead of the 2 walkways being supported the way originally intended, one critical connection now had to help support the walkway below it too. In simple terms, that connection was doing roughly twice the work, and it wasn't strong enough. That evening, with people standing on the walkways and a crowd below, the connection failed. The upper walkway fell onto the one beneath it, then both crashed into the lobby. 114 people were killed. More than 200 were injured. And there was another painful detail. Investigators found that the original connection design was already weaker than required. So this wasn't one bad change ruining an otherwise perfect system. There were several chances for someone to catch the problem. None of them did. 6. The airliner that ran out of fuel. Halfway through an Air Canada flight in 1983, the pilots received a fuel pressure warning. Then one engine stopped. A few minutes later, the second one went too. They were now sitting in a Boeing 767 with dozens of passengers behind them, and no working engines. The strange part was that the airplane wasn't supposed to be anywhere close to empty. According to the calculations before takeoff, there should have been enough fuel. Those calculations were wrong. The aircraft's normal fuel quantity system wasn't working properly, so the amount of fuel had been worked out manually. They knew the volume in liters. They needed the weight in kilograms. During that process, pounds and kilograms were mixed up. The math still produced a nice, clean answer. And when the calculation was checked using the same mistaken assumption, it produced the same answer again. So the Boeing departed with much less fuel than everyone believed. Once both engines stopped, the pilots had very few options. They turned the passenger jet into a glider and headed toward an old military airfield at Gimli. When they reached it, they discovered part of the runway was being used for motor racing. There were people down there. The pilots still managed to land. All 69 people aboard survived. A small conversion error had taken away both engines. Everything after that depended on the crew doing almost everything right. 5. The dam that was checked that morning. On the morning of March the 12th, 1928, William Mulholland drove out to inspect the St. Francis Dam in California. The dam keeper had noticed leakage that worried him. Mulholland was one of the most respected water engineers in the region. He examined the leaks, walked around the structure, and decided there was no immediate danger. Then he returned to Los Angeles. Before the day was over, that decision would look very different. Shortly before midnight, the dam collapsed. A huge wall of water rushed down the valley. More than 400 people were killed. Of course, the real story was much bigger than one leak. Later investigations raised serious questions about the ground beneath the dam, the location, its design, and the engineering decisions behind the project. But that's what makes the final inspection so disturbing. This wasn't a structure nobody had looked at for years. People had noticed something unusual. An experienced engineer had come to inspect it, and just hours later the dam was gone. Sometimes a warning isn't ignored. Sometimes people see it clearly and still misunderstand what it's trying to tell them. 4. When software became dangerous, people who came to a Therac 25 machine weren't doing anything risky. They were cancer patients coming to a hospital for treatment. An operator entered their information into a computer, positioned the machine, and began the session. Most of the time, everything worked as intended. But between 1985 and 1987, several patients received enormous accidental doses of radiation. Some were seriously injured, some died. Part of the problem was software. Earlier machines related to the Therac design used more physical safety protections that could stop certain dangerous situations, even if something else went wrong. The Therac 25 depended much more heavily on its computer. Under a particular sequence of actions, an experienced operator could enter treatment information, quickly change it, and leave the software in a state the operator did not expect. The screen could appear normal while the machine itself was not ready to behave the way the operator believed it would. And with radiation equipment, that's a very dangerous misunderstanding. The lesson wasn't simply that software can have bugs. Every large piece of software can have bugs. The real problem was allowing software to become such an important safety barrier without enough independent protection when that software failed. A mistake happening inside a computer had become capable of physically injuring someone lying in a hospital room. 3. Challenger. The Challenger disaster began before the shuttle ever left the ground. The night before launch, engineers from the company that built the solid rocket boosters were worried about the cold. More specifically, they were worried about rubber seals inside the booster joints called O-rings. Those seals were supposed to stop extremely hot gas from escaping. Engineers had already seen signs of trouble with them on earlier flights, and the unusually low temperatures expected before Challenger's launch made them even more concerned. They recommended not launching under those conditions. There was a long discussion between the contractor and NASA. Eventually, management approved the launch. The next morning, Challenger lifted off. 73 seconds later, it broke apart. All 7 crew members were killed. The physical failure began in one of the booster joints. But that's only part of why Challenger became such an important engineering case. People had already been worried about the exact area that failed. The warning didn't arrive after the accident. It was there the night before. The launch happened anyway. 2. The bridge. Everyone knew moved. People knew the Tacoma Narrows Bridge moved. It had been doing that almost from the day it opened in 1940. In the wind, the roadway could rise and fall so much that drivers could sometimes watch cars ahead of them disappear behind the waves of the bridge deck. People joked about it. They called the bridge Galloping Gertie. For a while, the movement seemed strange, more than frightening. Then came November 7th, 1940. That morning, the bridge started moving in a way people hadn't seen before. Instead of simply rising and falling, the deck began twisting. One side went up, while the other moved down. Then they reversed, again and again. The twisting grew until the structure could no longer survive it. Large parts of the bridge collapsed into the water. The footage still looks unreal today. A huge steel bridge seems to bend and twist, almost like it's made of rubber. You'll sometimes hear that simple resonance destroyed Tacoma Narrows. The real explanation is more complicated. The bridge was extremely flexible, and engineers at the time did not fully understand how wind could interact with a deck like this. The collapse forced bridge designers to take aerodynamic behavior much more seriously. It wasn't that engineers didn't know wind existed, they simply hadn't yet learned everything wind could do. 1. The error that grew for 100 hours. For more than 100 hours, a Patriot missile battery in Saudi Arabia had been operating almost continuously. During all that time, its computer had been making a tiny error when it calculated time. At first, the error was so small that it hardly mattered, but it didn't disappear. It accumulated. By February 25, 1991, the system's calculation was off by roughly a third of a second. That still doesn't sound like much. Until the thing you're trying to track is a missile. An Iraqi Scud was approaching American forces at Dhahran. Because of the timing error, the Patriot system predicted the missile would be somewhere slightly different from where it actually was. At the speed a Scud travels, a fraction of a second means hundreds of meters. The system looked for the missile in the wrong place. It failed to intercept it. The Scud struck an army barracks. 28 American soldiers were killed. And then came perhaps the most painful part of the story. The Army was already aware that long periods of continuous operation could reduce the system's accuracy. A software update had been prepared. It reached the unit at Dhahran the following day. The original computer error was tiny. It needed more than 100 hours before it became large enough to matter, but the missile only needed that mistake to matter once. Ending a socket, a hose fitting, a wrong unit, a steel connection, a software bug, a rubber seal. None of those things looks powerful enough to cause a major disaster. And by itself, usually it isn't. That's the pattern running through all of these stories. Someone makes a mistake. A check doesn't catch it. A warning is misunderstood. A backup isn't there. And the problem is allowed to move one step farther, then another, until something tiny isn't tiny anymore. The safest systems aren't systems where people never make mistakes. Those systems don't exist. The safest systems assume mistakes will happen and make sure one mistake isn't enough. Because sometimes the only thing separating an ordinary bad decision from a disaster is whether the next person, the next check, or the next layer of protection catches it.